I heard you are studying Pharmaceutical Inorganic Chemistry. Bet you haven't heard about reactions.
Reactions? You mean social media?
No, not these reactions, but these chemical reactions that is essential to life.
Like the digestion process, creation of salt, lighting a match, and so much more.
All linked to what we call chemical reactions. Sounds chemically terrific, right? Not so much. So, let's get started. Elements and compounds react with each other in numerous ways. Memorizing every type of reaction would be challenging and unnecessary, as they fall into one of the following categories. First is combination reaction, also known as synthesis reaction. It is usually a reaction wherein two or more reactants chemically bond and combine to form a single product. Simple visualization is when A combines with B to form a new substance, AB. Let's head for a concrete example. We have two molecules of hydrogen. On the other end, we have one molecule of oxygen. Combining these two will form one compound, which is 2H2O or dihydrogen monoxide. Second is a decomposition reaction, the inverse of combination reaction, wherein one compound, for example AB, breaks into two simpler substances A and B. Let's say we have calcium carbonate. When exposed to heat, it decomposes into two simpler substances, which is calcium oxide and carbon dioxide. Third, we have single displacement reaction. It is when a more active element replaces a less active element. From this equation, we can see that element A is more reactive and so it replaces B. Therefore, from A and BC, it turned into AC and B. But how are we going to determine whether an element is more reactive than the other? Simply, refer to this table of reactivity. Let us say we have zinc and hydrochloric acid. Zinc is more reactive than hydrogen. Therefore, we replace it to get zinc chloride and hydrogen. If we have single, then we also have double. I mean double displacement reaction. In this reaction, two compounds react with each other and exchange their ions to form a new compound. Let's say we have compounds AB and CD. When they start exchanging ions, they form new compounds named CB and AB. For this example, we have sodium hydroxide and hydrochloric acid. Now, we will be exchanging the cations, and we will have hydrogen monoxide and sodium chloride. For our last reaction, we have oxidation reduction.
Also known as redox reaction.
Redox is when one is being reduced while the other is being oxidized. Reduction is known to be the addition of hydrogen and electropositive element, while oxidation is known in simpler terms as addition of oxygen and electronegative element. So, here in our example, we have copper oxide and one molecule of hydrogen. When they react, copper oxide loses oxygen, resulting into copper alone, and hydrogen is gaining oxygen, which results to H2O. We conclude that hydrogen is the reducing agent which helps copper reduce oxygen, while copper being the oxidizing agent helps hydrogen to gain oxygen in the process. So in summary, the reducing agent is the substance that gets oxidized, while the oxidizing agent is the substance that gets reduced. Want some key takeaways? Let me rewind it for you. Combination reaction is when one product is formed out of two or more reactants. Decomposition reaction is when a reactant breaks down into two simpler substances. Single displacement reaction is when a more active element replaces the less active element. Double displacement reaction is when two compounds exchange their ions to form a new compound. And redox reaction is when one reactant is being reduced while the other is being oxidized. Now that we learned the different types of inorganic reactions and the conditions they can occur, we came to realize how magnificent reactions form. We may not see the bigger picture of how the whole reaction takes place, but through equations, we can imagine what it looks like. Till the next adventure, adios!